Hi, welcome to another episode of the Weld.com podcast, where each week we explore different pathways available in the welding industry. I'm your host, Beau Wigington, and this week we head back to Fabtech to visit the IPG Photonics booth to talk to Dean Brennan, the National Sales Manager for LightWELD, and Rex Alexandre, the President and Principal Engineer for the Handheld Laser Institute. We talk about the future of laser welding and places that you might see it popping up in the industry coming soon. We dive in right now. I came to Fabtech in Atlanta 2 years ago, and there was laser welders kind of here and there, and now it's just like lasers are everywhere in the industry. So where do you see handheld lasers going?
So I think of the quality manufacturers, whether it's us or we have some quality competition. We see that the people that are doing it right, doing the education, have quality machines, that's right. That's a rising tide. So we see the market actually growing, and each individual company will continue to grow in their sales. I think it's interesting with Miller and Lincoln Electric, and I think they're going to dictate a lot of the approaches people have about, they're saying now it's okay.
Yeah.
Right. It's okay.
It's like all the cool kids have one, so let's all get on board.
And it's okay. And I think that rising tide keeps it going. But I think it's really going to, at the end of the day, we're partnering with Rex Alexandre because we need smart people who know how to adapt the process to the existing codes, to understand, who already understand both sides, of the equation, and can really understand the application, because there's still great applications for TIG, still absolutely for MIG. It's just what is the right application, and somebody will listen to Rex. They're not going to listen to me.
Hey man, I've been listening to him all day, and I can do it even more.
I think Dean is right. A lot of it's like, how do you understand how to use the process, right? It's one thing to see all these Chinese lasers on TikTok. It's another thing to see Miller and Lincoln, very well respected in the arc welding industry, effectively recognize it as a legitimate process, right? Yeah. I think the other part of the equation is, how do we get AWS and other code books to officially accept it? Now, there's ways that we can go through the code and make welds to code. I'm on a handful of AWS subcommittees to get handheld laser added into existing code. Right? I think that's another big part of it. But as the technology continues to mature and people will continue to understand it, and I think as the price eventually comes down as we move into the future, it will be a very normal thing. Yeah. Right? And this is why I quit my job at SpaceX, right? I had a very well-paying job, very high up at SpaceX as a welding engineer, and I see the wave coming, right? And I think it's evident with Lincoln and Miller and all the other lasers that you see here at the show this week, that people recognize the capability.
Yeah.
Right? So it's coming. We just need to understand how and where to use it.
It's got to start paddling to catch that wave, And
it started to me as a curiosity at SpaceX. And when I left SpaceX, I would, walk through the office, or I'd be sitting down at lunch, and I would always smile because someone would be talking to another person about handheld laser like it was no big deal. Just like they were talking about using MIG welding or TIG welding. And that's the change that I want to see in the industry, and I think that change will come.
Yeah.
Right?
I didn't even think about that.
Yeah, so that's what I'm here. I want to see that change in the industry to where it's just a normal thing. It's another tool in your toolbox. It's nothing weird, it's nothing fancy.
It's just welding.
Just welding.
Just welding.
Yeah.
Well, what are some of the biggest misconceptions people have about the process?
Two of the biggest misconceptions that people have. Number one, that it's super dangerous, right? And number two, that it's weak.
Yeah.
Right? Everybody says, it's cold, right? And I mean, I get it. You watch some of these videos, some of them are fast forwarded. It looks really fast. You don't see the part getting very hot, right? And sometimes I watch these videos and I'm like, yeah, that looks cold. And so I get where people are coming from, right? And so one of the things that I want to do as part of the Handheld Laser Institute, I have a metallography lab, I have a tensile testing lab, along with all my lasers, and I want to start generating that data and showing people, look, it's actually not cold, right? We can actually get deeper root penetration with the laser. Here is the mechanical performance of an arc weld versus a handheld laser weld, right? And we can, I think, with data, dispel a lot of these myths. but nobody out there, nobody's generating that data.
Hey, we're
right?
trying, man. We're trying.
Yeah.
We're definitely trying to show people what it's all about, because there's not a ton of like tutorial videos of like, here's how you do this, here's how you do this. So we did like laser versus MIG, TIG versus laser for stainless steel. Like, we're trying to do all that, but I would love to see like the super scientific testing, because I think that's all people talk about is like bend it. Like, that's all we hear is bend it.
Yeah.
Like, do a bend test, destructive test. Like, so I agree with you.
Once you start understanding the process and what it's capable of, and this is kind of the process I went through at SpaceX, you start to figure out how to actually make structural joints, which in many cases can actually outperform arc welds of similar sizes.
What are some uses people might not be thinking about right now?
Well, a few things that I see the tacking capabilities, where we can actually do some tacks that are as strong as a spot weld.
Yeah.
And we see people doing large enclosures where they're doing the spot welding maybe at the end of the application, where normally when you're putting together an assembly, you're spot welding when you can get it into the throat of the spot welder.
Yeah.
And so we see a lot of tacking applications. We also see a lot of applications where it's very versatile with like square tubing and frame building, because there's no, when you're doing a frame, if you're going to use a TIG or a MIG, you're half of your fixturing is not for just holding it in place; it's to keep it in place while it's cooling. And there's
no cooling.
You see, you're not adding all that heat, so you're not distorting, because a frame application is just a gaggle. I mean, it can go anywhere that heat's going to take it.
Yeah.
So we see a lot of adaptation, and one thing that we can actually slow down the welding process. So we can actually pulse the laser, and we can go to half speed, or 60% of the speed. And what you get, if you're using wire, you actually wind up you're stacking dimes.
Yeah,
it's done mechanically.
We did. We messed around seeing, like, we wanted, like, because welders, they love to stack the dimes and everything, and so we did a video showing how to get those stacked dime looks and everything in there with the laser.
I'm really tired of talking about how fast it is, because in reality, when you're making something, if I'm going around an angle or something, I'm going to slow the darn thing down. I got to be able to.
I didn't even know you could.
It's still a craftsman operating the machine.
Yeah.
And it's just like in the old days, I'm an old guy. In the old days, you'd come out, the press brakes, you'd have these press brake operators go, I don't want that machine because it has automatic crowning. Well, he's great at taking phone book pages and shoving it under dies and making his own crown. He has all this skill. But in reality, once he got a more sophisticated machine, he was able to do the next level of performance. And this is the exact same thing with laser welding, because when we just talk about, it's easy, we put anybody on the machine, that is so elementary.
Yeah.
If you want to do advanced welding, you need to have somebody that knows what they're doing. They're great welders, and now give them a tool that takes them to the next level.
Yeah.
So I think Dean is right. A lot of people say anybody can handheld laser weld, right? And I think it's true. Anybody can make a coupon on the table.
Yes.
Right? And now, when I first started working with IPG, I would have their people come out and they trained me. They trained some of my welders, right? A year and a half later, I called up my buddies at IPG and I said, hey, I need you to come back. I'm going to train you how to make parts.
Oh, dang.
Right? It's one thing to make a coupon on a table. Right now, when you're welding production hardware, the stakes are higher, you're out of position, you're welding more complex geometries. It does require that skill, right? And so how do you give people that skill and teach them to weld these more complex parts? It does require more teaching.
Be right back after a quick word from our trusted partners. Tired of your old abrasives wearing out too fast and not being able to get the job done? Check out the Cubitron 3 from 3M. We got the chance to have some hands-on training up at 3M with their Cubitron 3 lines, and these products remove metal and cut extremely fast. They have options in cut-off discs, grinding discs, and if you have a whole lot of material to remove fast, fiber discs. Head over to 3m.com to learn more. Need a gouge, cut, grid cut, or even mark metal? The Thermocut XtraFire handles it all. This versatile plasma power supply is your one-stop shop for manual and mechanized cutting. From the workshop to the shipyard, Thermocut has you covered for industrial-grade cutting with heavy-duty performance.
But to circle back, right, you asked what applications are not being done yet.
Yeah.
Where I see the industry right now is people are mostly just welding that thin sheet metal, right?
Yeah, that's like the first thing. Everyone's like, sheet metal,
right?
dude. Like,
and nobody believes in the process from a structural standpoint, right? I mean, you see all of those videos on TikTok, right? And this is something that drives me nuts, right? You see all these videos on TikTok and all the welders are, oh, you know, number one, you're gonna go blind, be careful. And then number two, that little weld, it'll never be strong, right? But there's no information out there about it, right? I've made a weld with a 50 thou leg that outperforms a TIG fillet with a 160 thou leg, right? That's because you can penetrate deeper. It's all about how you design your process and design your joint to get that strength with this new technology. So I think one of the next big steps for handheld laser welding as a whole is how do we get into these structural welds? How do we convince people that it's structural? But then also how do we weld them to code, right? So I do a lot of work with people doing stuff to D1.1, D1.2, D1.6, and nobody really expects in the beginning that it can be done to code or have these high-strength structural welds, but it can be done.
Interesting. Yeah, I think that is just, you nailed it on the head. There's not enough information out there, you know, just because it's fairly new. When did handheld lasers come into the market?
Well, so laser welding in general started 25 years ago with CO2 lasers.
Interesting.
So this is not, welding with light is not a new thing.
Yeah.
What is new is I can make that safe.
Yeah, I think that's a big thing with laser welding in general is the like safety aspect. Like for me, I was really scared actually. I was like, this thing can hurt me fast, you know? It's like, but like, what do you tell people when it comes to the safety aspect? Because what you were just saying at the beginning, I was like, you can't be in the room, you can't even be in the same state, you know? Like, so how do you make people more comfortable?
And I'll tell you, like, I myself was really uncomfortable with it originally. So all my background is in automated laser welding and cladding and additive manufacturing, right? So when you're doing these big automated laser systems, it's always its own enclosure. There's laser safe glass. You're on the other side, right? And so to me, I was like, well, this is freaky, right? I don't want to be in this room with this laser. Early on, before I would weld, I would always put my hands up under my welding hood, and I'm like, okay, I got my glasses, I'm ready to go, right? Realistically, it's a very safe process, right? Especially with all of the safety, as Dean mentioned, there's a lot of unique safety features with the LightWELD. So my first exposure to handheld laser, right? 5+ years ago, the only thing on the market were Chinese machines, right? And laser safety was not much of a consideration, right? When IPG first came out with the LightWELD, that's what turned me on to handheld laser welding. And I said, well, hey, if IPG is doing it, it must be serious, right? The safety features that are built in to these machines make it an incredibly safe process to use, right? It's just like any other industrial process, right? A brake press, it'll take your finger off. A lathe, it'll rip your arm off, right? You just have to use the proper PPE and the right protocols, and it's a very safe process, right? So to date, you know, I've been using these machines for 4+ years now. I've trained hundreds of people how to use them. I've never encountered anyone who's actually had an eye problem with handheld laser. It all comes down to wearing the proper PPE. The only issues I've seen from a safety standpoint are many arc welders are used to just putting their hand on the part when they're tacking it up.
And you get a nice little hole.
And you just burn a hole through your glove real quick. You only learn that lesson once. Right? And you let go of the trigger real fast. But that's really the only safety issue I've encountered. You wear your glasses, you get to be safe.
As far as things I need to have in my shop to bring in a laser welder, like do I need special power or anything like that?
Yeah, so you're actually going to use less power. So a 1500 watt laser welder is going to use at full max power is going to be 23 amps of 220 single phase.
That is
wild. It's very low. You need a shield gas. We're a laser company, so of course we never spec a flow meter. We use a pressure regulator, so we're off on the wrong foot with all the welders at that point, right?
Hey man, it's just one more thing to learn, right?
But yeah, you're gonna have a shielding gas, and you're gonna have an operator, and you're ready to go.
Yeah. So Dean's right. Really, it's 220 volt single phase, 30 amp breaker, right? Small power compared to a lot of the arc welding stuff that you don't need a 50 amp breaker, right? You've got your shielding gas, which often for carbon steel and stainless steel, we're running nitrogen instead of argon, right? This is one of those things that's going to be different for arc welders, and it was different for me originally too, right? I was making butt welds at one point, and in X-ray I couldn't get rid of this porosity, and the guys from IPG were dumbfounded. They're like, well, we're using nitrogen, it should be fine. And I made some side comment about, oh, well, let me adjust the argon flow on the back purge. And they were like,
don't do
you're
any.
using argon?
Yeah.
And I was like, yeah, it's fine, right? It was the first time in my life I had ever heard the phrase argon contamination, right?
Yeah.
Crazy.
Today is the first day I've ever heard that
I
in
know.
my life.
So then we switched the back purge over to nitrogen, and the porosity went away.
Do you know the science behind that?
So basically what happens is nitrogen is well documented to stabilize the keyhole in welding, in laser welding, right? So I don't know the exact mechanism of why nitrogen makes your keyhole more stable than argon, but in carbon steel and stainless steel, it does stabilize that keyhole, and it reduces what we call keyhole collapse, where the molten pool will cover up the keyhole and entrap that pore in the bottom of your weld.
That's crazy.
Yeah.
Like my mind is just, I'm playing through all of the things you just described in my mind, and like keyhole, I don't think keyhole when I think laser welding. I think keyhole when I'm stick welding. That's pretty much when I see the keyhole the most. Mm-hmm. But do you, you don't really see the keyhole when you're laser welding, or do you?
No, you don't really see the keyhole, right?
Okay.
Now, if we had like a high-speed camera, high dynamic range, and we were looking at the melt pool, yeah, you would see the keyhole.
We can't see it, but a camera could see it.
Oh, totally.
Okay.
Yep.
Interesting. I want to see it. I got to see it now.
I've got some friends with the right camera. We'll hang out sometime. We'll do it.
Hey, that sounds like...
In Seattle, yeah.
Why do you think welders are so hesitant about laser welding?
I think a lot of it is because it's just a new process, right? Yeah. And there's no information out there about it, right? We've been, as humans, arc welding for over 100 years, mm-hmm. right? There's a lot of information. We're still learning, don't get me wrong, but there's a lot of information, right? You can Google any arc welding technique you want to learn. You can find a video, you can find information. Everybody understands arc welding safety very well, right? It's a very well understood process. We're still in the infancy of handheld laser welding, right? You can't just go ask Mr. Google how to handheld laser weld.
How do I handheld laser weld?
Right?
Yeah.
And so I think, there's a little bit of trepidation because people don't understand the process, right? People think either it's dangerous and it's weak, or it's some sort of like TikTok joke, right? But I think a lot of people are also very comfortable with what they know, right? Yeah. And I've trained a lot of welders, and I feel like sometimes it's about a 50-50 shot as to whether someone's willing to give it a chance, right? But as soon as these welders get a chance to weld and take a step back and see what it's capable of, I've seen a lot of minds change, right? Yeah. It's just, you need that knowledge to understand why it's different and how it works.
Yeah, well, it's that aha moment. Even when, no matter what process you're learning, you fight it. You fight that process until you have that aha moment where you're like, this is what it's supposed to feel like, and this is where I'm supposed to have my body. Mm-hmm. So, I get that. That's the trepidation of trying to just go through that failure period of learning something. Understand maybe welders would be a little hesitant, but...
And sometimes, it is a more expensive process to get into. And so really it's not the welders typically that are buying the machine. It's the people that hire welders that are buying the machine. Yeah. And I think just because daddy says you're going to do it, there's some pushback also.
Oh, yeah.
So even though a business owner may be saying, hey, I'm gonna help you be more efficient, help us all be more efficient, there is some pushback from an authoritarian type of approach.
Yeah, it's just like, no, I've been MIG welding in your shop for 10 years. Don't change it up on me.
Yeah, it's not really a gradual process to introduce this. It's you flip the switch.
Well, what is your both of your advice for people that want to get into laser welding?
Yeah, I think, if someone's asking, where should I be? What should I be doing? What should I be aware of if I want to get into handheld laser welding? And I think Dean said something that's great. Just don't be afraid.
Yeah, I
right?
like that too.
You have to take that leap of faith, right? You have to forget some of what you know about arc welding, right? Take that leap of faith. Find some initial application, even if it is something super basic, right? And often I think it starts with very thin sheet metal, right?
Yep.
Take that leap of faith, give it a shot, forget some of the things you know about arc welding, and then start asking questions, right? And doing experiments and trying to figure things out, right? Welders, we're a curious bunch,
We
right?
sure are.
We want to
We
fool
sure
around,
are.
we want to break stuff, we want to see what happens, right? So don't be afraid, one, of the process. It's safe, wear your PPE, but then don't be afraid to play around with it and try to find ways to use it. That's how it started for me at SpaceX. Welding parts we couldn't weld any other way. All of a sudden today, SpaceX has hundreds of lasers, and there's lots of welded parts that have been to space and come back, right? You just have to start playing.
Yeah. And you could weld a spaceship one day. You never
could.
know. You
Yeah.
never know. Well, I really appreciate y'all for chatting with me. If people want to learn more about IPG and the LightWELD, where should they go for information?
Yeah, well, you can find us on the web for sure, and we'll be happy to talk to you. So give me a call.
Give them a call.
And on my end, if you need training, support, qualification, development, code questions, handheldlaserinstitute.com. You can find me.
Handheld Institute, handheldlaserinstitute.com.
That's right.
Well, I really appreciate you guys for chatting with me.
Yeah.
This was
Thank
a lot
you.
of fun.
Thanks a lot.
Enjoy the rest of the show, and I'm sure I can't wait to go and see your lab.
Yeah.
That
We'll have
sounds
a lot of
awesome.
fun.
Yeah.
Yeah.
Well, cool.
Thanks again for tuning in to another episode of the Weld.com podcast. And thank you, Dean and Rex, for sitting down with me. It was a lot to learn. And Rex, I really hope I can visit the Institute someday and get some hands-on training. I can't wait to see what the future holds for laser welding. I also want to give a huge shout out to our trusted partners, 3M Abrasives and Thermocut, for helping make the show possible and helping us all learn about the different pathways available in the welding industry. If you have a topic you'd like me to cover, reach out to me on the Weld app at Beau did it, or shoot me a message over on the Weld.com Instagram account, and I'll do my best to find someone who's knowledgeable about the subject to talk about it. I just want to say thanks again to everybody who's been tuning in each week. It really means a lot to have your support, and I hope that you've been learning as much as me. Until next time, we'll see you out there.